All right, my Ivy physicists, we are almost done with this set of notes. The next part is going to be something called stacked graphs. That's actually a preview for your next homework assignment. And this next homework assignment is 9.3, but it's page 3.6. Too many numbers. I'm sorry. So page 3.6 is your next homework assignment, and this is kind of like a little preview of it. And so what they are is these things called stacked graphs. And they are stacked graphs with position time, velocity time, and acceleration time spaces. And so what you are doing is you're trying to say, okay, if this is the position time graph, what will the velocity time graph look like? And you might be panicking right now. If you're panicking right now, that's cool. Chill. You'll be okay. I'm going to zoom in a little bit just to make things a little nicer. Oh no, that doesn't make things nicer. Chill, really, you'll be fine. Because the key idea here is that you're using the graph qualitatively. Qualitatively means like with words, not with numbers. So we're describing what is happening in the graph. So if we look at this graph, you can kind of say that it looks like it starts out really steep on this position time graph. So really steep on a position time graph would mean that it's going really fast. And then it gets less steep, and then it gets even less steep, right? So you can qualitatively describe what is happening. So what that means is that we can qualitatively say what the velocity is. Well, it's steep position time graph, so that means a high velocity. Less steep means a lower velocity. Less steep means even lower velocity. Or in other words, what I'm doing is I'm kind of saying like, okay, what's happening at the beginning, what's happening in the middle, and what's happening at the end. Kind of like we're looking at like the slope at 3 sections on the graph, or just a couple of sections on the graph. So that means then I can translate this down to our velocity time graph. Saying, means high velocity, so I'm going to have a high velocity, lower velocity, and actually the lowest velocity, well, not the lowest, but 0. We get to that sort of flat line look. And so I can say, that means that my velocity time graph is starting at a big positive velocity, really steep, getting less steep, getting less steep. So we're getting a smaller and smaller and smaller velocity until we get to a velocity of 0, which would mean that the position time graph would just stay in the same position over time. And then we're going to use that same process to go from our velocity time graph to our acceleration time graph, because we know that the slope of this velocity time graph, that is the acceleration time graph. The slope here is negative. So I'm going to translate that down to a negative acceleration. Hopefully you're tracking with me. Hopefully you've written this down at the bottom of your notes here on 3.5. And so that's not too bad. Again, we're using this idea that the slope of the line of my position time graph tells me my velocity time graph. Then the slope of this velocity time graph, that tells me my acceleration time graph. So then I have another example for you. And this one, we're actually starting in the middle. We're starting with the fact that we know the velocity time graph starts at a velocity of 0 meters per second, and then it becomes negative. Okay, you can do this. So if I want to translate that to my position time graph, you might say, let's look at the area under the curve, and you could do that. We know that the area under the curve is going to be small initially, and it keeps getting larger. So the area under the curve starts out small and it keeps getting larger, but key fact, it's negative. So that means that the object is moving backwards. So I actually think that qualitatively means in words, kind of like thinking through what's going on. Area under the curve is pretty hard to think about qualitatively. I mean, yeah, I'm gonna stand by that. Quantitatively, if we had numbers, we could do some calculation. But qualitatively, the way I think about this is that I go through and I say, okay, first, we start out here with a velocity of 0. So a velocity of 0 means a flat line in the position time graph. So I'd start out with a little bit of a flat line. Then we have a negative velocity. That means a downwards slope. So I'd have, I don't know if my arm is pointing downwards, which, I can do this. Yeah? No, I think it has to be this way based on the camera mirroring me. Anyway, it has to have a downward slope next. So we start out with flat, and then we get a downward slopey bit. And it keeps getting more negative velocity. So it gets more and more downward slopey. So what that looks like is I start out flat, I get more and more downwards slopey because these are negative velocities. And so that means I can kind of sketch in this line here, make it a curve. Again, why are these so large? I don't know. I made them a long time ago. And then we can go ahead and fill in our acceleration. That is also negative in this example. And again, I can tell that because the slope of my velocity time graph is negative. I think going from velocity time to acceleration time is actually the easiest. It's where you're trying to go maybe position time to velocity time or velocity time to position time. I think those are the most challenging. But what I would really recommend doing on these is think them through logically. Think through, okay, if the slope starts out flat, that means that the velocity starts out at 0. And then the slope becomes more negative, so that means the velocity becomes negative. So talk it through and think about what does that mean is happening to the object, and what's that going to look like on the slope of my position time graph or my velocity time graph. So what I'm going to ask you on this question is actually to think about what does it mean is happening to the object in this particular graph. How would you describe the motion of this object? And so really trying to make sure you feel like you understand what is happening in this position time graph. Good luck, and let me know if you have any questions.